We're now only at number 7. Are we all excited, or do we just want to leave now? So number 7 is broken authentication and sessions. There's not a lot to say about this. ASP.NET gets it right. What I would say is, for the love of God, don't ever roll your own. Generally, no offense, you're going to get it wrong. These things are hard to do. Use what's there. It works. It works well. And that's pretty much all there is to it. One thing that does get asked every now and again is, how should I validate a session with every request to make sure that the session hasn't been hijacked? Well, ASP.NET does a pretty good job of stopping session hijacking by making the session cookies HTTP only. But if you're paranoid, what people tend to do is they go, well, what I'm going to do is every request, well, the first request that comes in, I'm going to shove an IP address into a session variable, and then I'm going to check it again and again and again. Incredibly bad idea, because that doesn't work with AOL. Pretty much every single mobile broadband provider in the UK. It doesn't work if you're browsing internally at Microsoft to an outside site, because God knows what proxy you're going to go through, and a bunch of stuff like that. So IP address is not what you should be checking. If you must do this sort of thing, probably the safest thing to do is check the browser string. Now, it's not a particularly good way of identifying individuals, I will admit. However, the browser string is unlikely to change in the lifetime of a user session. They're not going to install IE8 within 5 minutes. It's as simple as that. So if you want to validate sessions, browser string's pretty much the only thing that you can do. At 6, we have information leakage. And we're back to shoddy code and demos. So symmetric stuff, that code is good. It's the only good code you'll see in the download package. Oh God, no. You do what you want with that, I don't care. So, how many of you store custom objects or custom strings in view state? So if I do view source, and here's my view state value, so that looks okay, right? That's not plain text. Something's happening to it. This is not encrypted by default. This is base64 encoded, which is just a fancy way of doing plain text. So, if I use this thing called view state decoder, I can extract view state. I can click decode, and it brings out everything that's being stored in view state. So I can see that I've shoved something in view state with an index called secret, and it says that Ben Hall is really 47, which is shocking for anyone that's ever met him. So you don't store secrets in view state, obviously. You can actually get ASP.NET to encrypt view state for you. There are options to do that. So if you must store something secret in view state, turn the encryption on. Next, we have that. How many of you have seen this on a website that is not your own? How many of you have seen this on a Microsoft website? Would that be Channel 9? Yes. This is a bad, bad thing. This is a bad, bad thing for a number of reasons. One, there's source code. Two, there's a nice stack trace. So this sort of, leaving raw errors on. And admittedly, they're not on by default, but people do turn on raw errors when they're trying to debug something and will forget to turn them off. Is not a good thing. So, how do we get rid of that? Come on. Custom errors, correct. custom errors are better. Sorry, I'm just worried that you would then pick that up, Ian. Custom errors are better, but they are not the best thing to do. Because with custom errors, by the time it gets to your custom error page, you don't know what the error's being. You can't log it. You don't know what to do with it. You just know that you're a custom error page. And also, custom error pages are easily detected by automated scanning software. Because what custom error messages do is they send a redirect request back to your browser, and that's detectable. So what's the other option? Anyone? Okay. Hello? I heard someone go.
I think you can send emails.
Email. Well, okay. So we do. Yes, email is probably what we do when we know an error has occurred, because we want to log our errors, and we want to log our errors because we want to see where the problems are. Phil Winstanley has this really interesting tool called Exceptioneer, and maybe one day he'll give me money for saying that, which actually sits there in your ASP.NET application and catches exceptions. And every now and again, he'll fire me through this really weird exception, which is a bizarre web request, and say, what's that? And it's detected SQL injection, or it's detected some sort of cross-site scripting. So you want to log your errors so you can examine them. So the problem with custom error pages is, well, by then it's a bit too late. So if I go down to Mr. Error Handling, there is an event in individual pages, and indeed in global.aspx. But I'm sticking it in Mr. Individual Page here. There's an on-error event. If you override the on-error event, you can do what you want. So what I'm doing is I am doing server.transfer to error page. And I'm doing server.transfer because when that happens, the execution of this has not stopped. So I still have my errors. I still have the stack trace. I can do whatever I want in errorpage.aspx to log and notify me of any errors. And also, because I'm doing a server.transfer, we don't see this go back to the browser, tell it to go somewhere new. So that's not detected by automated scanning software. So this is a better option. And you can do individual ones in your page. You can do it in a base page class, or you can do it in global.aspx. Happy with that? Cool. How many of you are using the Ajax Script Manager and WCF to produce your Ajax services? No one? Ah, hello. Oh, two. Okay, so when you write a web service, generally we have this, I can never remember what I've called this, so hold on a minute. You browse to the web service and you get loads and loads of information about the web service. The methods that are available, the objects that you call them with, the stuff that is expected back. We can see why this may be a problem, right? This is something that you generally don't want exposed. So people that write web services will turn metadata publishing off as soon as possible. When you've generated your proxy classes, metadata publishing goes off. And all we do is we do service metadata HTTP get enabled equals false. And the ASPX, the Ajax web services, do this for us automatically. So when people look at that, they are generally incredibly smug because they think, well, it's not particularly a problem. However, because of the way that Ajax services work, we need a generated piece of JavaScript. And the generated piece of JavaScript basically contains everything our WSDL would. So if I go view source on the page, if I go back to the right place, ooh, there it is. we have this. Script source equals time service.svc. Now it says JS debug because I've got a debug compiled assembly, but frankly you can get the same information out of one that's compiled in release mode. So if I go and bung this in here, it dumps an unknown file type. I'm going to save that on my desktop. I'm going to open up Notepad, and I'm going to open it eventually. And this is the proxy class that gets generated by the web services. And we can actually see a lot of the information that a WSDL would get. There's my method name. And if I scroll down, eventually, and I usually get lost, here's the path of the service, and we've got parameters in here, and all the stuff that you think is hidden because WSDL generation is off is exposed by script generation. And there is nothing that you can do about that because it's necessary for Ajax to work. However, what you can do is for each web service you expose the minimum amount of stuff possible. So what I have seen is I have seen people that have a myriad of web services because they believe that SOA means we should expose everything. And so they call them step 1, step 2, step 3, step 4. And so because you're exposing this stuff, I can start immediately calling step 3 just to see what happens. And with each step that you add, that's another method, another potential avenue of attack. So you want to just squash them all down into one great enormous block, and have this sort of monolithic thing. Okay? We happy with that as a concept? The other thing to note is update panels. How many of us here use update panels? How many of us know that update panels are generally bad and unscalable? Update panels are inherently more secure because update panels do not expose anything like this. They post back to the page where they came from. And ASP.NET's pipeline takes care of everything. So nothing is exposed except for the fact that there's a piece of JavaScript going back. And that's it. So they are more secure. However, they are big, unscalable messes. So you pays your money, you takes your choice. So, like I say, we shouldn't show raw error pages. People are enormously guilty of this. God knows that I do it when I'm trying to debug something remotely, and there's not a lot you can do. Catch errors properly. Use the onError event. It's there. Don't upload your PDBs or debug assemblies, because if you do leave raw error messages on, then you start getting things like stack traces and source code. You can encrypt parts of web.config. There is a utility in ASP.NET that will do it for you. So things like connection strings, which have hard-coded usernames and passwords if you haven't set up NT authentication for SQL. Encrypt it. Encrypt view state if you must store secret things in view state. Another good one is watch your CSS. A fun one is to look at the style sheets for a website. And look for style sheets that have admin, or style names that have admin in them. And what you can find is that somewhere along the line, someone's decided to be nice and fancy and do round buttons, or to do some sort of fancy background, and that is different for their admin directory. So it lives, you can see a directory path to something that may well be their admin directory. So that's just another example of information leakage. You want to do fancy things, put all your admin styles in a separate admin style sheet that's in your admin section. And like I say, Ajax update panels are more secure. And if you are exposing web services, expose the minimum amount of methods necessary to do what it wants, and turn off WSDL generation as soon as you can. We happy with all of that? No questions? Cross-site request forgery. This one's fun. Simple bank site. I click transfer. The money transfers. Okay? Yeah, all right. You'd have logged into the bank beforehand. They'd know who you are. There'd be a lot more checks. All right? But this is just a demonstration. So if I go back, view source, save it. So I have a local copy on my desktop. Up comes Notepad again. Notepad's great. The EU said that they wanted to introduce laws that would outlaw hacking tools. So Notepad would have gone. What I'm about to show you will mean that the browser would have gone. This is great. So, here we have our form. And we can see that it's pointing to a relative URL. So what I'm going to do, work out where it's supposed to be. Shove that in there. So there it is on the desktop. I'm going to load up my desktop version. You can see that all the style is gone and it's coming from C users. Okay? What happens when I click transfer? You may laugh. I chose a banking website for a very good reason. There were a bunch of students last year who decided it would be interesting to look at some of America's larger banking websites, government websites, to see if they were vulnerable to this thing called cross-site request forgery. And a particular bank was. Now you may think that this is not much of a problem because all I'm doing is submitting something from the desktop. So imagine that you have authenticated to your bank and then you've gone off to do other things. And by accident, you have navigated to www.badsite.org. Badsite.org knows the form layout for your bank. And on a page in badsite.org, it has this form, and it submits it via JavaScript. It gets submitted to your bank, and this happens. Because you're already authenticated to your bank, because you've been doing some banking stuff earlier in the day. Do we now see where the problem lies? This is called cross-site request forgery. And it happens because authentication is held by your browser. And an authentication cookie may be dropped. And it will travel in backwards and forwards to its originating site. So as long as that cookie exists, any type of form submit going to that site will send the cookie with it, and you will appear to be authenticated. It gets better if you're not using form post requests. If you're doing naughty things with the URL and GET requests, well then, I can embed an image tag with the right URL of a height 0 and a width 0, and it will happen in the background. So there are a couple of ways to fix this. There is a view state user key if your users are authenticated, and you can set that, and what will happen is when I go to a website, the view state for that website will be locked to me. When the attacker goes to the website, they will get view state that is locked to them. If I then go to the attacker's site, and they've constructed the form, well, it has the wrong view state user key in. So if they try and submit it, an exception gets thrown. However, this requires that you know who your users are. You have a unique way of identifying them. The classic way to do it is you insert what's called a canary, and it is a unique value for a session. GUID, whatever you want. And you also drop a cookie. And the cookie is computed from that unique value. And if those two things don't match up, then an exception is thrown. So that's the sort of thing that you do to prevent yourself against cross-site request forgery. This is a bit of a pain in the ass, admittedly. So if you are going to use a view state user key, you need a way to identify who the user is, and you must set it in page init. Every single page where it's going to be used. Because if you set it later on in the life cycle, it's too late. It needs to be checked before the controls start getting created. If you want to use the canary and the token, there is anti-CSRF, which is mine. I'm very proud of it. Which is a little tiny HTTP module which sits in the ASP.NET pipeline and writes canary values into all your ASP.NET forms automatically. If you don't want it, you have to opt out a particular form. View state user key, you have to opt in every single page. Anti-CSRF, you opt out individual pages. I like the opt-out method because it means if I add a new page, I don't have to remember to do something. Because you are now all worried about your banks, the way that you stop this, just in case, is you log out immediately. You've finished using your bank site or any important site. So you should be encouraging your user to log out. And any GET request should you shouldn't be doing damaging things from GET requests. But this leaves an interesting question about when is a postback not a postback. Does someone want to make a stab about when is postback is true? No? Okay. So there are two main types of HTTP requests. A GET request, which is where everything is in the URL, and a POST, which generally comes from a form. Would anyone like to hazard a guess about what a postback is? A POST request. You would like to think so. Unfortunately not. ASP.NET considers something to be a postback as long as all the hidden fields are there. So view state, event validation, and you can take a form and you can take these things and you can put them in the URL. So you knock yourself up a simple form which just has a button on it, has something in view state, has an event behind the button. You hit submit, that's a post. It's fine. And is postback will be true. If you then go back, do a view source, take these values out, put them in the URL, hit return in the URL, so it's a GET request, is postback is true. Now to me, this is incredibly bad. To the ASP.NET team, it is a will not fix by design. So everywhere where you currently check if page is postback, you should be checking the HTTP request verb and making sure it's post as well.
By the way, in ASP.NET MVC, you can do it
The MVC stuff is an entirely different kettle of fish, and yes, it does it particularly well. It also has its own anti-forgery token attribute that you can apply to a form or to a controller, a view. Yeah, I'll get there eventually. But it is, again, opt-in rather than opt-out, but it's built in. Oh, yes. And the anti-CSRF stuff, it looks for things that are dangerous as GET requests, and it will reject them. At 4. Oh, sorry. Does anyone have any more questions on that? Because you all want to go home. Or the pub. At 4, we have direct object reference. Here we have a messaging system. And if we look at the top, we can see that message ID equals 1. So we know what we're going to do with this, right? So, do you remember the furore with the Junior Doctor application system, MTAS, 2.5 to 3 years ago, where people said it had been hacked, and what would happen was when it was hacked, you could see the details of junior doctors on the site. And that would include their exam results, their names, their addresses, national insurance number, sexuality, religion, results of any medical test, results of psychiatric evaluations, and so on. And there was a big fuss about this. And it turns out that it wasn't hacked by anyone clever. It was hacked by a junior doctor who saw that there was a direct object reference in the URL and started adding 1 to it. So this is a big problem. And it's called direct object reference because, well, this is message number 2. Previous one was message number 1. So how do we think we go about stopping this? Encrypt what? You could. Yes, that's very true. It's probably a little bit heavy because you'd have to decrypt the parameters in every query string, but that's certainly an option. So there's one option. We need to check that, in fact, I am Ray, because I've not done this. So we need to check that the object that we're displaying belongs to the user that wants to display it. And that's sometimes enough, but if we do things like that, then, well, if I got an access denied here, I could go 3, 4, 5, 6, 7, 8, and so on and so forth, and if these were order numbers, I could work out how many orders your company has. So we use what's called indirect object reference, because direct objects are bad. And basically we have a lookup table somewhere, and it has an exposed ID, which will be a GUID, or a cryptographically secure random string. Because GUIDs can actually, if you generate GUIDs quick enough, you can tell what the next one's going to be. Do it. Go home, write a loop that just prints out a new GUID each time, and you will see that it's actually quite easy, because some of it is time dependent. So we have some sort of random number, and basically when that comes in, we use that as a key into our system. Now it's an extra lookup, yes, but it's extra safety. We happy enough with that as a concept? Cool. Malicious file execution is more a PHP thing, I have to admit, because PHP is interpreted. How many of you accept uploaded files to your websites? Why is it always you two?
Because we're terrible developers.
Yeah, okay. So, what type of files are you accepting?
PDF.
How do you know it's a PDF?
By file extension.
By file extension.
I'm being facetious.
Yeah, okay. So file extension is normally what people do. And file extensions can be lied about by simply renaming them in Explorer. So what's the next step after that then? This is unfair now, but...
you could read the header of the file.
Aha! Yes. So next step after file extension is usually to look at the MIME type, and that can be lied to as well. There's this plugin for Firefox called Tamper Data. And you turn it on, you submit a form, and that pops an alert box saying, would you like to tamper with this form before you submit it? And it has all the values, and you can change them to be whatever you want. So MIME type's not believable. So when you start accepting files, the only way to be sure is to parse it. So if it's a PDF, you look at the header. In fact, probably what you want to do is load it into a PDF library and make sure that there are no exceptions. If it's a doc file, you load it into a doc file parser. If it's a GIF file, you load it into the image class, and so on and so forth. There is no other way to do this. There is no other way to check that the file that's coming up is correct. And frankly, it's going to go wrong somewhere along the line. So other things that you want to do is you do not want to have them directly exposed on the file system. You want to have some sort of little buffer sitting there, a serving script that serves them up, not with direct object references, of course. We want to use indirect object references. And we want to store these things outside of the application root, preferably. So they're not inside our application. Even better, we want to store uploads on a completely separate hard drive. Certainly to our operating system, because otherwise if people start uploading 2-3 gigs of stuff, your operating system drive may well get filled. And we don't believe anything. If you have to keep them inside your application, store them in app data, because there's no execute permissions on there, and people are not going to be able to get to them directly, because ASP.NET enforces that. We happy with that?
Yep.
Injection flows. Does anyone want me to go through SQL injection? Because I'm aware of the time, and normally everyone's seen it. With the download, there are step-by-step instructions on how to completely screw up a SQL Express database that is included with it that will tell you what you need to type in. I can go through it, or you can have fun at home. But we know what SQL injection is, right? We're all happy with that as a concept. Okay. I will show you the instructions so you can be reassured that you can have fun with it on your own. Toggle instructions. And that will talk you through how to get the contents of a username and password table. We'll also illustrate to you why you should not be storing clear text passwords. We should be storing them as spot. Yay! Okay, so I'll skip past SQL injection because, frankly, everyone's seen it. It was fun the first time.
I have a question.
Yes?
Okay. With most ORMs, I know linked to SQL you can create a query, but with most ORMs that people are probably using, is this as much of a problem?
So, if you trust the ORM writer, and you trust that they have used SQL parameters, or you have SQL store procedures in place, or you are only accessing views, then it's fine. You really shouldn't give things access to your tables. Certainly not write access. Read access, yes. You should be funneling write access through something else, like a store procedure. However, people are getting turned off by store procedures because it hides logic in your SQL server. So people are now turning to ORM. So you need to look at the ORM code, and you need to be sure that if it's doing inserts, it uses SQL parameters. And if it uses SQL parameters, you're safe. Unless you have a stored procedure, which in turn creates its own SQL. Now, this is not as uncommon as you think. This is how searching generally works. So you accept this great big list of words, and you go, right, well, I now have to build my select dynamically. But even within SQL store procedures, you can tell those, the generated SQL, to use parameters again. The other thing to watch out for is XML. XML and XPath has injection. So if you are storing your usernames and passwords in an XML file, God help you. You can use parameterized XPath queries by implementing the XSLT context on an XPath query. It has got to be one of the most ugly .NET classes I have ever seen. It is horrible to use. So you download MVP XML from coplex.com, and it presents XML parameters just like SQL parameters. You use them in exactly the same way, and it does it all for you. And at number 1, and after this we can go down the pub, is cross-site scripting. I love cross-site scripting. I think it's hilarious. So, I searched for me, because I'm incredibly vain. It's true. That's fine. Now I searched for a script tag. And because I have echoed back user input, that script tag is now inside my page, and it runs. So it just runs an alert box. And that's not particularly harmful, unless it's on your mate's site, on his blog, and you've done it to the comments page of his blog, which his mother reads, and you've put swear words in there. It was funny at the time. I still think it's funny. However, so window.alert, little bit boring. So the problem we have is that basically everything's getting echoed back. And if I do view source, we'll see eventually I stole all this from Google, and my God, but their style sheets are just horrible. So there we go. I searched for script, window.alert, hello XSS, and it's just spat it out. So this is now running. Bit boring, alert box, who cares? Next one then. Window.alert, document.cookie. Ah. Oh. So this is now taking all the cookies for the current page, in fact the current website, and I shoved them in an alert box. Alert box again, not very exciting. So instead of spitting out window.alert, what if I did document.write, wrote an image tag, and for the source of that image pointed to somewhere on a server that I control, and I appended the cookies to the path of the image as parameters. I now have all your cookies. If you have rolled session yourself, this may well have a session ID in it, and I can recreate your cookies, go back to the website, and I'm you. You will notice that the ASP.NET session cookie is not there. That is because there is this concept of HTTP-only cookies, which was a Microsoft invention, which has been accepted by all the major browser manufacturers, apart from Apple, who really don't give a damn about security and are ignoring it altogether. And so if you mark a cookie as HTTP only, it will not be available to JavaScript at all, unless you're in Safari. So that's what we do to keep cookies safe. But if you need to manipulate cookies or you need them to go backwards and forwards via script, then they need to be marked. But Ajax sends HTTP-only cookies with it. It's just you can't manipulate them. So don't worry about Ajax authentication cookies. They will work. So we can manipulate the entire document object model. So I can start inserting things into the page. So if you imagine this would happen on a financial website, you can start faking up pricing information for shares. Or if you're really, really creative, you can start messing up and changing press releases. It really depends. So you can see that this is actually can be quite serious. It's a bit of a giggle because you can do really, really silly things like document.location. So document.location equals katyperry.com, and off it's gone. And that's interesting. It's really, really badly written. But hey, what did you expect? It's like most of her music. So eventually up she pops, and off she goes. So you can see that this is kind of a bad thing. So there are ways to fix this. Not Katy Perry's music, but the problem. So if I go down to XSS, instead of directly echoing, I encode it. I hit search, and it's changed this into &LT, &GT, and so on. Anytime you spit something back into a page, you should be encoding it, no matter what. There are different ways of encoding. This is HTML encoded. If you are spitting back a URL, it should be URL encoded. If you're spitting back JavaScript, it should be JavaScript encoded. VB script, it should be VB script encoded. HTML attributes have their own different encoding, and so on. The .NET framework by default has server.html encode, server.url encode. Yeah, that's it. There is a Microsoft-produced library called Anti-XSS, which has been released as open source on Coplex, that produces JavaScript, JSON, XML, VB script, JScript, and a bunch of other useful stuff. Plus, it's tested against the big fat master list of XSS vulnerabilities, of which there are about 70, and that's what they use for their unit tests, and they give you the unit test package. So I would honestly use that in preference to the ones built into the .NET framework, even though the anti-XSS stuff, like a lot of things on Coplex, is in permanent beta. But it's open source, what you expect. So I would definitely look at swapping that sort of thing out. You may think, I'm a smartass, I can do this myself. So we have image source, JavaScript, alert. That actually does something. That will pop it up. So you look for JavaScript, and you strip it. Oh, okay, well, I'll do a case-insensitive search. Okay. So then I have this, which is actually the same as that. Because ampersand hash 106 is J. And you think, okay, well, what I'll do is I will run this through a decode one time. So I can encode this again. And this would be ampersand amp, semicolon, and so on and so forth. See, there are numerous ways of encoding things. Don't do it yourself. Simple. So we should treat all input as evil. If we want to spit things out, for example, we have a blog post or a blog commenting system, and we want to allow some HTML, bless you. The thing to do is you work from a whitelist, so I'm going to allow breaks, paragraphs, bold, italics. You strip out everything, then you put your whitelist back. What you don't do is go looking for things that aren't in your whitelist and then take those out. It doesn't work. Eventually, someone will come up with something that's clever enough that looks like it's on your whitelist, but isn't. When you store stuff in your database, don't store the encoded version, server.html encode, server.url encode. Because what happens if there's a vulnerability in those and they're updated? Your stored versions may well be vulnerable, and you don't particularly have a way to go back. So you store everything unencoded in your data, and you encode it when you spit it out. Little bit of extra processing time, but a darn sight safer. Use HTTP-only cookies, and use the anti-XSS project. Now, if you're really lazy, the anti-XSS project gives you an HTTP module which attempts to do things automatically for you. This is a last line of defense. It may not always get it right, and there are no guarantees. So encode properly, but use the last line of defense because that's what it's there for. And if you want to look at all the different current ways of getting around cross-site scripting filters, hackers.org/xss.html has them all. And it is impressively scary. So, are we happy with cross-site scripting as a concept? Anyone got any questions? We've gone through the top 10. So, resources that are basically just there, so when you lift the slides out, you don't have to remember what I said. PnP Guidance Explorer is great because it gives you a bunch of things that you should do in certain circumstances. You want to secure communication between two internal machines, talks about IPsec. You want to secure between an external and an internal machine, talks about SSL. Fiddler tool is fun because you can watch things that go backwards and forwards between your browser and your web server. You can replay them. You can edit them and replay them. One of my friends was being really, really smug on Twitter about certain referral URLs that he was getting from what he thought were important bloggers. So I sent about 1,000 requests with a faked referrer URL of fbi.gov/10mostwanted. And he got a little bit worried. So it's another example of why you don't trust anything that's coming from the browser. You don't trust anything that comes into your system. You should be looking at it. You should be sanitizing it. You should be checking that it's safe. Tamper data, great fun. Hit a button, change a form variable, even ones that are hidden. Very lovely. And basically that's it. Does anyone have any generic questions? I mean, remember, you can email me questions if you have something specific about what you're worried about. Normally, there usually is someone that's very worried. I think the most fun I've had giving this talk was a couple of years ago, something on roughly the same subject, which I gave to a bunch of students at Norwich University. And their IT support people were sitting at the back of the lecture hall, and midway through they left. And they didn't come back because they could see the students going like that. So, anyone have any generic questions they'd like to throw out there? Hello?
Hi. In Internet Explorer 8, some pages are shown like being XSS vulnerable, but they're actually not. And why are they doing that?
So Internet Explorer 8 shows false positives for cross-site scripting. No script, which is sort of the equivalent for Firefox, also gets a bunch of false positives. The great one that it gets is verified by Visa. It gets that incredibly wrong. So I then have to actually spin up IE when I want to purchase something, because I don't use IE by default. If I want to purchase something, IE gets it right in that case. It's basically because what may look like an XSS attack may in fact be valid. There's no other way around it. These things are best guesses. So IE8 may well get it wrong. There is a submit feedback button. I'd encourage you to use it.
Were you using IE8 when you were showing your stuff?
Yes. And IE8 didn't detect it. It's because I have that turned off. I cheat. So sometimes it will get it right, sometimes it will get it wrong. You can't. One of the weirdest things I saw coming out of the IE8 thing was if we get this right, then no one will need to encode output ever again. Bullshit. You should never depend on the browser to get anything right. Period. Always encode, always be paranoid. Everything that comes into your website is evil, and treat it as such. Anyone else?
Silverlight. Is there anything specific around that in terms of vulnerabilities and cross-site scripting?
Well, Silverlight isn't scripted.
Yeah, fair enough.
So there are no cross-site scripting vulnerabilities. The fun thing to look at Silverlight is Silverlight provides very limited support for hashing. There's all the SHA-1s, SHA-256, SHA-512. It only supports one or two symmetric algorithms. It only supports one asymmetric algorithm. Problem with Silverlight is it has no concept of a secure string. So, and it has nowhere to store secrets because it has to be portable. So how do you encrypt in Silverlight when the password may be sniffed from memory? You can't embed it in your assemblies because people can use Reflector. Silverlight is kind of a problem. I would not do anything sensitive in Silverlight right now. Silverlight 3 is apparently introducing some support for some of the web service security stuff. But I haven't looked at it in any great detail because my Silverlight design skills are minimal. I can put a button. I can click the button. That's about it. And the button looks ugly. So, yeah, Silverlight, basically, treat Silverlight as a UI or as another HTML page. You don't trust anything that comes into your back end. You don't trust your front end to actually work properly because people can get at it. It's just another view, nothing more. It's a richer view, but you don't do anything secure on it. It's like trusting JavaScript validation to run on your HTML page when people like me run with no script because I don't want JavaScript turned on by default. It's just something you don't do. You still validate it at the back end. And you should be treating Silverlight exactly the same. Any other questions? Hello?
You mentioned Geneva and claims authentication.
Okay, yes.
So which vulnerabilities will it help us with out of those?
Claims authentication doesn't help you with any vulnerabilities. What claims authentication does is it provides you with a federated and delegatable identity system. So I can, for example, if I wanted to, Passport. Passport's almost a federated identity system. So I log into Passport, and if I have a website which has is Passport protected, or sorry, it's Live ID now, isn't it? Yes, sorry. So if it's Live ID protected, I'm trusting Live ID to do the authentication for me, and I get a very minimal amount of information back. OpenID works exactly the same way. Geneva just does it in another different way, as SAML or by using information cards, which are an infinitely more secure way of transferring it. But the interesting thing about that is, how many of you have used impersonation in your ASP.NET website? So someone logs in as, yes, okay. Someone logs in as an NT user, and you turn impersonation on, the thread is now running as that NT user. And then how many of you talk to middleware, which then in turn talks to the backend in that sort of scenario? Identity gets as far as the middleware, can't go any further. Bit of a problem. So what Geneva, in fact, what all claims-based identity does is, well, the claims are transportable. You send the claims to the middleware. Middleware goes, oh, I've got these claims. It can then re-sign them saying I've trusted it, and it goes off to the backend. The backend goes, oh, here are all these claims. Now, it's come from someone who trusts the person that I've trusted. So I'm going to check that this person is actually allowed to know, I'm sure this identity is right. Now I can check that they're allowed to do what they want to do. So it provides for a better flow of identity. That's the big thing for me. I mean, there's information cards, it's got SAML, it's got all sorts of passive federation, you can do single sign-on with it and stuff like that, and it's all kind of cool and trendy, even if it is undocumented right now. But identity flow, claims transformation, all that sort of stuff, that's the biggie for me. But Geneva does not address any of those. It is another authentication method. That's all it is. Although I'm sure if the Geneva team see this, they'll go, there's more to it than that. Yeah, there is, but that's the main thing. Anyone else? Thank you very much for being so attentive. I'm sorry to have kept you from the pub for so long. I know you weren't expecting me for all of this evening. I can only apologize. And when the person that dropped out does eventually turn up, you can beat him. Thank you very much.